Hello, everybody. Oh, it's pretty loud. My goodness. Okay, I'll have to watch that. But looks like it's 4:20, and it's great to see all of you here this time of the day, at the end of the day, before we're getting ready to go have our little social event. And anyway, it looks like it's a pretty good group here. So welcome, and we'll go ahead and get started. The title of this, in case you're not in the right place, is This is Terminology Services on FHIR. So I'm glad to see all of you here. And a little quick disclaimer about the licensing for the presentation. It's available for folks under Creative Commons, like all of our FHIR presentations, so you guys can use this as long as you give credit. If you need to use it for something, that would be perfectly great. We'd love to have you do that. And a little bit start off about myself. Who am I? I'm Rob Hausam. I'm an MD. I'm an informaticist. I've been working working in the terminology field for quite a while and in other aspects of informatics and data standards. I'm a co-chair in the in HL7 in both the vocabulary and the orders and observations work groups. And I'm involved with the FHIR specification, including being the terminology module editor, and have been actively involved in this for quite a while. And so that's a little bit about me. And it'd be good to find out a little bit about all of you as well, if we can. I know we can't obviously go around the room or anything like that, but it'd be good to get some sense of your background and interest, if we can do that. So maybe we can get a little quick show of hands, find out who's clinical or technical. So who would say they have from mostly a clinical background here in the room? Okay. All right. And then I assume that means that everybody else is technical, but you can raise your hands. Yep. Okay. So, all right. Very good. That's good to know. I'm not surprised by that, of course. But so let's talk a little bit about where we are in terms of terminology, because we're going to be trying to cover quite a bit of material in a very short amount of time. I usually give a similar talk at the HL7 meetings, tutorial, over about 3 hours, and we have about, 40 minutes here. So I've tried to really condense it as much as I think I can, but we'll see how that goes. But as far as your familiarity with terminologies, that's the next thing. So a lot of technical folks, many of you, I'm sure you've run into codes now and then, a lot, but I don't know how familiar you are with the other concepts. So would you say, raise a show of hands, who's getting started in this area? Okay. So it looks like a number of you. We may need to close that. What about more moderately familiar with terminologies? Okay, it looks like that's probably the majority. What about then, would you consider yourselves more or less experts in terminology? Okay, and a number of you guys too. And I know a few people in the audience can keep me honest on some things, but that's good. And so what about using terminology services in particular? Not just terminology, but terminology services. Have any of you done that in an application, whether it's in FHIR or not? Okay, I've got a few, yeah. Any of you done it yet in FHIR? Okay, and a few of you there, same one. So very good. So that's pretty much about what I would have expected. So yeah, go ahead and take a seat. Yeah, oops. All right, so a little bit about what we're going to try to cover. I'm going to spend a little bit of time, go through it pretty quickly, I think, because most of you probably already know all this bit, but about where you find all the stuff on this in the FHIR specification. Just going to show you where it is, and then we'll go into more, do a bit of an overview and review for probably many or most of you about just how things work with coded data in FHIR, because we always got to go back to the fundamentals there, and then we'll go more into the actual terminology services themselves, and a little bit about why we need them and why we think you should use them, and just a little bit about the history, what we've had before we've come to this point with FHIR and terminology services, and then go into a little more details about what's available, and then how can we use the capabilities that we now have. And I would, we don't have a lot of time, like I said, and we've got a lot of people, but if you have questions and you'd like to, things aren't clear, or you want to talk about something that I have glossed over or something like that, please speak up. Because I've had to cut quite a bit of stuff out, and I'm pretty sure I've cut out things that are probably important to a number of you here, and you may just have to pick it up, at a separate time or whatever. But please ask if there's anything. So, all right. So again, a little bit about where to find things. So we'll go into that. So the first bit is there's a link right at the top of the FHIR specification. I don't know if you all have seen it, but right there, terminologies. And so if you're trying to find things, code systems, value sets, and concept maps, that's your first place to check. It's got them pretty well organized there and laid out, and you can get to things that you need there pretty quickly. So you need to know about that. And so basically that takes you into this, and so you have your code systems, value sets, and concept maps right there. And if you scroll on down, there's basically a table of all the various ones, including various code systems and value sets that are defined by FHIR, and also ones from our earlier standards families, V3 and V2 are there as well, and a number of others. So that's there. And the FHIR spec also has the notion I mentioned earlier of the terminology module, which is basically at the level 2 on the home page, and again, it's right here, and it kind of tries to, at least the intent is to organize things in a place where you can easily get to them. And if there's anything that isn't doing for you that you'd like it to, it'd be good to mention it on the terminology stream in Zulip, or put in a tracker item or something so we can make it better. That would always be good. Okay. And when you dive into that, you basically see this little diagram and some other material, and then it kind of organizes things around the various resources and data types and operations, the terminology service itself. So that's what's here. And so the main part we're trying to talk about is right here in the middle, which is, some documentation, kind of explaining the terminology service. And I'm probably going to do this. I'm probably going to go back and forth between singular and plural here, because we really have the notion of there being a terminology service in FHIR that includes all of this stuff, but we kind of tend to think of these things as individual things, and so I'll often kind of speak of it in the plural as terminology services, and probably most people will end up doing that as well. But so within the terminology service are these, basically of these different operations, and we'll talk about details of at least most of these, not all of them. There's some that we'll save for more, future times. And then the coded data types at the bottom, which are, what we have to pass around, the codes, whether we're doing it in the REST paradigm or in messaging or however we're doing it, we have to use coded data types. So, all right. So, any questions at this point? Yeah, got a question. It showed what? Birth sex. Oh, birth sex. That's probably, somebody, if you know better, I'm thinking my recollection, I think that's only defined in the U.S. core specification, I believe, yeah. So you probably want to look there. You should be able to find it there. Yeah, I don't think it's going to be in the standard, the base spec anyway. Okay, so we'll move on into looking at basically, again, the overview and a bit of a review on the coded data. So saw that basically the bigger diagram in the terminology module page, but this is the first part of it. Again, the fundamental building blocks are code system and value set. Again, I'm assuming you guys, if you went to Dan's talk yesterday, you heard about it, and if you've done anything with terminology, you know about this stuff, so we won't spend a whole lot of time on it. But code system is here, basically define a set of concepts that have a coherent meaning. And and then we have value sets that basically take those codes, typically from one or more code systems, and they select them for use in a particular context. So basically the code system defines the concepts, and the value set, selects a set of concepts, from one or more code systems. So those are the two, fundamental bits. And I will mention, I guess, it might be good, a little historical a bit. And prior to SQ3, these were really all combined into one thing. They were all part of the ValueSet resource. And in SQ3, by the time we got there, we realized that we really needed to treat, code systems as their own first-class, entity or, first-class, resource in FHIR. So that functionality was split out and now is its own separate thing. So if you're working in DSTU2, you might not know what I'm talking about entirely on some of this stuff, but because it has changed. Anyway, so moving on from that, let's jump all the way to basically an instance of coded data. So you're passing around your resources, and you've got, you've populated the elements, with your data. And so what you're going to have there is, again, you've got your code system and your value set, but you've got, you've got the element definition, and this is where in the spec you're going to be, setting up your bindings to terminology. It's where we hook the the information model to the terminology model, and we take an element in a FHIR resource, and we say this is the set of concepts or codes in some terminology that you want to use for this particular element, and we can do that with a few nuances, which we'll talk about in a second. But this is where we do that. In element definition, we bind to a value set, and I'll emphasize this again one more time, probably on another slide, but and then the value set selects from the code system. But then when we get down to the actual instance of data itself, it's got a coded data type. Then it's either a code, a coding, or a codable concept, and that refers back directly to the code system. It conforms to the element definition and the binding, but it only refers to the code system. It does not go back and refer to the value set. There is a way to do that if you need it, but we really think that most people, most of the time, don't need to do that. But there is an extension for value set reference if you need to use it. But typically this, basically the meaning, again, the meaning of the code and the concept comes here. And it's not, the context is useful for a lot of things, but the meaning still should be defined here. And by referencing that in the instance, that should give you the information that you need. Does that make sense? Okay. All right, so we talked about bindings. I mentioned a little bit about binding strength. And we have 4 types in FHIR that we've defined. And starting from the most restrictive down to the bottom, I'm actually going to go bottom up, I think. You probably see in the course spec most of the time, most of the bindings are going to be example bindings. And these are codes that basically give you an idea of what you might use for terminology if you're trying to, to get actual work done. But they don't say you need to do this. You can basically, you're free to do what works for you. And I actually had a question about this just a couple hours ago, earlier. There was not, it wasn't, maybe this isn't entirely clear, but the fact that we say have a binding to SNOMED CT and some elements, or LOINC on others, or whatever it might be, as an example, doesn't mean that you actually have to use that in your application. If you're in a different context that uses a different terminology, you're free to use what you need. Preferred, we go a little bit farther and say you should use this. We think this is a pretty good set. We'd recommend that you do it. We'd like you to do it, probably. But if there's some other good reason why you can't or don't want to, then you still can, do your own thing, basically. Extensible raises the bar a little bit higher, and quite a bit higher, but not all the way. And here, the rule basically is that you must use the specified codes if they apply. The kicker is how to determine if they apply. That's not always quite so straightforward. Sometimes it just requires a human understanding of the codes and what they mean and your data, and it's not very computably enforceable. And we've been having a lot of discussions about that lately, and so there may be some more things coming along for that, so you can kind of stay tuned for that. But then we get to the last bar, which is the required bindings, and you see a lot of that in structural elements, statuses, and various things. And you basically say if you're going to send data here, you got to use these codes. You don't have a choice. You can't go outside and use a different code system or anything like that. Sometimes if it is codable concept or whatever, you might be able to send a translation. But if it's just a code element, you pretty much either have to put one of those codes in there, or you have to omit the element if you can't find something. So that's the rule for that. And so just kind of one more emphasizing, sort of the difference between binding and, what happens in the data element instance. The binding specifies the value set, and this is an example with observation. You basically would make the value set reference to a value set of observation codes. That set in this case happens to include all LOINC codes. So maybe it should be a little bit narrower than that, but that kind of works. And but again, that's going to be an example binding in that case. But the data element instance specifies the code system. So if you had an observation instance, you'd be doing things like this. You'd be setting the system to loinc.org. You'd be setting the code to some specific LOINC code, and you could give it a display. You don't have to, but you could. But if you do, it's supposed to be a display that LOINC themselves have actually defined. It's not one that you just kind of make up on the fly. Yeah. So that's there is a place to put that, and we'll talk about that, but not there, not in display. Okay, so that's again gets us to the data types. So the code it's just the code. It's nothing else. Just one thing. The code system and the value set are fixed. They're fixed when you do the binding, and you don't have any flexibility to change that. We use them for when we have things that are really standard, that are internationally standard, required for everybody to use everywhere. That's using FHIR. Typically in structural kinds of things. And with coding, then we can do more. We've got we basically have both. We can specify it's a code and it comes from a code system, and we abbreviate that by just saying system. And both of these are actually optional, interestingly enough, but both are almost always present because it's not very many use cases for using one without the other. There are a few, but particularly you can use a system basically to say I wanted to put I would have put a code in from this code system, but I didn't find one, so I'll say I use the system, but I don't have a code. So sometimes there's things like that. But you can also put display version, and you can say whether it's user selected or not. But those are all optional. Codable concept again just takes the notion of coding and says we can have more than one of these. We might need to translate. We might need to have a different, might we need both SNOMED CT and ICD-10, for example, and I could send both in the instance if I know what they are. So I can have one or more coding instances, and I can also add text if I need to, and I can even send only text. If I don't actually have a code, I can just send text, and that text is supposed to be either the text entered or chosen by the user. So, all right. So now I'll get quickly to the resources. And the code system resource, like I said, it was split out in STU3 from ValueSet, and its main purpose is to declare, and describe the existence of a code system and its key properties. It may or it may not list some, of the concepts in the code system, and along with that, their basic properties, could be again code display and definition. Plus, also you could have additional display terms, which we called designations or additional properties, and that's defined by the code system publisher. So LOINC's got a set, and SNOMED has a totally different set, and some code systems don't really have properties. But anyway, this is and that's what you can do in code system. And basically, you can declare what's supposed to be there, what can be there, but it's not intended to support the process of maintaining a code system. So we're not expecting SNOMED International to distribute and publish the new release of SNOMED CT using a FHIR code system resource, nor LOINC. Neither one of those or any of the other big ones. We don't intend. We wouldn't expect that, and it probably wouldn't work, and probably in any of our servers if they tried. So at least not yet, anyway. But that's not the intent, and we can declare how they're supposed to work in our system. So we'll talk about that a little bit more too. Anyway, but it's not intended for distribution of any of these big code systems. So that making sense? Any questions? Yeah.
So is there a way to designate how you can impose coordination of the code system inside the resource? Or is that...
Yeah, actually there is. And probably quite a bit of nuance. Oh, sorry, let me repeat the question. Yeah. So the question was, is there a way to designate how or whether you can do post-coordination in a code system? And the answer is yes. You can basically declare that the code system is compositional, and you can also describe basically the parts of it that can be used to construct expressions. SNOMED CT is a great example of that. I mean, you can, we have, the list of all the SNOMED CT relationships are properties in the code system, and they can be used, and there's a defined expression, compositional expression grammar, syntax that you can use to put those together in logical ways. And then, I didn't mention it before, but all of the data types, the actual code field itself allows us basically an arbitrary string, and so you can put in a valid compositional expression if the code system supports that, and you can declare in your code system resource that it does. So, does that answer the question?
What if you have your own?
If you have your own
Coordination syntax.
If you're defining a code system and you have your own syntax, you can declare that it's compositional, and you can't actually describe the actual syntax inside the code system resource, but you can definitely indicate where to find that and how people should use it. And typically what we've done is we have pages in the FHIR spec that talk about how to how that can be done. So we have a page for SNOMED and for LOINC and all that, and we could have one for yours too. Yeah. Is there another question? Okay, so the question is about whether this, I think, see if I can rephrase your question, but we know that code systems change over time, and some of them slower, some more rapidly, but I guess the question is whether this is talking about that and whether it's not intended for that activity to be done here. And I think my answer is that we don't expect the FHIR mechanisms to be used to do that activity, but we do expect the code system publisher to be doing that activity, and then we'll expose that, using the FHIR code system resource. We'll update if things change structurally, we'd update that, and the content behind the scenes in the server would get updated, and we track versions so that you can know which version you're on, and you can leverage that in your queries and all of that. So. All right. I don't know how we're doing on time. It's a lot of material to cover, but so ValueSet resource, again, they reference code systems by their URIs, but the code system may or may not always be a FHIR code system resource. Like I said, we started out not even having a code system resource. So, it is possible that a FHIR server can reference a code system that doesn't expose the actual code system resource. That's really okay. You have to have a stable URI for it. It doesn't have to be a URL. We recommend it, but it doesn't have to be. But you have to have a canonical way to identify the code system, and then you can reference it. But it's best, I think, in the FHIR world to have either the publisher of the code system generate a code system resource that describes it, or if they don't do that, which some of them don't, then FHIR can create a code system resource that says, this is how we describe how that code system works. So you'll see some of that. Let's see. Sorry. So value sets specify the allowable contents for the coded elements, and we align them with our HL7 value set definition spec, but some parts of that are in extensions, not in the core. The composed element is, kind of in the guts of the value set, represents what in VSD is called the content logical definition. And emphasis on definition here, because you basically define a value set, and then we get to this next part called the expansion. Those are the two big pieces of a value set. We have a definition, and then we, at some particular point in time, runtime in general, so to speak, would be you would basically take the rules of that value set definition, you would basically process that against the current content of the code system, and based on either today's date typically, or if it's specified otherwise, it could be a different date. But based on whatever date it is, you would say that this is the set of codes that's that basically is generated from that definition for this code system, and that becomes your expansion. That's what was returned to you, and that's what you would be using, actually to do all the work in FHIR. If you basically say this is the set of allowable codes, and we know that the reason we have this expansion is because that can change over time, and sometimes the code system may change, whereas the definition of the value set may not have. Maybe you want all codes that are, let's say bacteria and SNOMED. Well, we know they're going to be finding new bacteria all the time, and SNOMED may add new codes. And so if I expand the value set, today, I'll get a certain set of codes. But if I expand it 6 months from now, if I've updated and SNOMED's added some new codes, then I'll get those new codes in my expansion. And that's what I really want most of the time. Now, sometimes you might not want that to change, and then you can control that if you want, but we know medicine's moving on, and we have to move on with it, so we have that ability. Okay, so let's see. So I'll try to. So basically, you select the concepts, and you name the code system, and optionally with a version. And if you just include the system, like I mentioned earlier, then that basically means all codes. So if you wanted to have a value set of all codes in a code system, you just reference the system, and that says, if I say LOINC, HTTP, ://LOINC .org, that means my value set definition is all codes in LOINC. Most of the time I don't want to do that. It's a little bit big, but occasionally. So let's see. So anyway, I can select the codes by property using a filter, and there's some, you can name it, and there's different operations. The equals is an in is a set membership basically from a value set, and regex for manipulating strings to do matches there, and then the value. And so an example would be using LOINC, you might have basically specify a filter for the component property, and you'd say it's equal to sodium, and so you get all LOINC codes that have sodium. Yeah, question. Go ahead. Mm-hmm. Okay, so the question is about human language translation, and it's a good question. We have some ability to deal with that, but it's an area I'd say that's kind of only marginally explored. I mean, the honest reality is that most of the work has been done so far by English-speaking people, and a variety of flavors of either, really starting in Australia, I'll give them first bill, but in the U.S. and the U.K., and other English-speaking countries. So we've seen most people have had most experience with that, but we have now. I don't know if there's any of our non-native English speakers. I'm sure there are in the room. Well, I know there are some, but. Certainly we can deal with language, but we do it as additional designations, and if you're in Germany, you can create a value set specifying, the German display terms for, put those in your compose. But you really, I guess the real bottom line answer is you don't even have to ideally worry about that. Display is an optional element. It's the code that matters, and the code. The notion of it is it's common across all languages, so it should be independent, really. All right. Sometimes that's easier to make work than others, but that's how it's supposed to work. Okay, slide about ConceptMap real quickly. This is a way that we can, make equivalences between code systems. We need to do this a lot. Like, I don't know, just a quick example. If you had a diagnosis code in SNOMED and you needed to, send, a claim, for billing, reimbursement, or, credit, for the activity, you'd probably, in the US at least, you'd probably have to use ICD-10 for that. So you might need to have both the SNOMED code and the ICD-10 code, and you want to know, maybe how to get from one to the other. So this is the kind of thing that you can start to do here. The ConceptMap provides the data that's used in the translate operation. That's just an example there. And this, got one slide, I actually don't have any examples on it, but that's an exercise for later about terminology-based search. And just to say, this is still not quite actually into the terminology services themselves, but the searching capability of FHIR allows you to leverage some of the terminology capabilities. And the simplest one is, the token, where you can basically search on a code system and the actual code, and you can do both. So you can, look for those specific combinations. But then you can also deal with the modifiers. You can, again, token-based modifiers included text, so you can search on various texts in the coded data type. And so we're talking about maybe if you're searching for, say, all observations with a particular LOINC code, you can, and if you know the LOINC code, then you can be real specific and say it here. If you just kind of know what it is, and I want all codes for sodium or something like that, you can do that as a text, using text and hopefully find all those observations that way. Or you can say, I don't want those, and you can use not to do that. You can also do it based on value sets. It's either in or not in a value set, and so if you happen to know, a value set that way, you can leverage that. Or you can do it on some assumption, which is a, relationship. So, cat is a mammal or that type of thing, but so you can say above or below. So it just presumes that your code system has a hierarchy, and you can, try to find all, say you're looking for all pneumonias, and you want to find, but SNOMED's got about 200 codes for pneumonia or something, and you want to find all of them, you can use a below search, with the code for pneumonia, and if your system supports the SNOMED CT hierarchy, it should be able to find all the observations that have, or all the condition resources that have that. So, okay, just do a quick time check. All right, so a little bit about well-known terminologies. Dan talked a lot about LOINC yesterday, but we got, SNOMED and LOINC and RxNorm and UCOM and others. They have specific mappings into FHIR, the resources. So that we basically typically provide standard code system resources for those, and those resources, you can specify the filters and properties, and you can define things we call implicit value sets and also implicit concept maps that can be used directly from the terminology. And the bit about LOINC, again, Dan covered it really well yesterday, so I won't spend much time here, but there's a canonical code system resource for LOINC, and you can actually get it in two places, at least that I know of now. Maybe there's others too, but we can get it on the LOINC FHIR server now here, and we've got, it basically defines, what the properties are of the parts. It's got the 6 LOINC axes and a number of others. You can use that in filters, and you can filter on these other things, when you're defining your value sets. And there are existing value sets for answer lists, and there's now value sets for LOINC groups. And there's got an example you can look at for those if you want. And there's all the implicit value set defined. So for LOINC, is this all codes in LOINC, and all code systems have an implicit value set, of all codes for those, which you can reference if you need it. SNOMED is a similar idea, except they've got a little more complicated in their URI because they've got multiple editions and versions and all of that. So you have to make sure you're using the right, not just the date version, but also the proper edition. So if it's international edition, could be potentially used anywhere, but it's not specifically used anywhere. At least there might be a few places, but usually each realm has their own. So there's a US edition and a UK edition and an Australian edition and all that, and you have to be specific about that, where it's appropriate. There's a canonical resource that we've published for that. There's various properties that are defined, and then the filters, can do. You can basically say whether you can do subsumption, and they call reference sets, or like we call value sets, typically in HL7. There's also expressions that you can do. So you can SNOMED you can post-coordinate, and so you can build, basically queries that are, expression queries that, can be used to find codes in, and use it in a filter. And you can also say whether you allow that kind of post-coordination or not. All right. And there's the implicit value sets and implicit concept maps. And, I'm just going to quickly show one of these. And I know we're running short on time, but and this we make a lot bigger. Should be able to do that. Well, unfortunately, that isn't working. Oh, maybe it's big enough, but okay. Anyway, I can't show the detail I'd like here, but basically, this is, that is getting big. Oh, yeah, there it goes. Okay, it took a while. All right, so, in fact, okay. That's maybe a little bigger than I needed. Okay, but anyway, just go back here a second. So basically what I hit on that one was, this is the one by subsumption. So I was looking for all SNOMED codes under this particular SNOMED CT code. And if we can see what that is, yeah. So we're basically getting all the ASMA codes is what this one's doing. And so this was not at a predefined value set. This is something that's intrinsic to the code system itself. And we picked a particular code, and then it was able to leverage the logic and be able to find out all of the the codes that should be in that value set, as if we had created a value set resource, but we didn't. And this can be a pretty powerful thing. It's particularly for systems like SNOMED and LOINC. So it's good to know about that. Okay. Yeah. The trouble is that's hard to see. Let me see, maybe it's not because it's up here. There it is. I think you can really see it. Yeah, it's basically, yeah, I apologize for that. That's just not possible to see it, but I can show you that later if you want to see it. So let's, so like I said, a lot of material to cover, but I don't know, let's see. Yeah, I'm probably supposed to stop in about 3 minutes. But, okay, so the terminology services bit, which is, why should I use them? Well, the main reason is that there's a whole lot of complexity with the coded data. We've been talking about it, and you guys, I'm sure, have seen it. But most applications are a lot simpler than that, and we don't want to deal with all that. So what we want to do is delegate all that complexity to the specialty software, and provide a set of services that do what the applications need, making it at least a lot easier, if not easy, to write applications that do terminology stuff really well. So that's the goal. Really brief bit of history is, this is not the first time we've talked about doing this, and it's been talked about a lot, actually, but it's been hard to actualize. And so there was a prior HL7 specification with OMG to do the common terminology services, and you can go look at it if you want, but it's not been really widely adopted. And, it's probably it's probably ahead of its time and all that, and, it just kind of needed the synergy that we've gotten now in the FHIR ecosystem to be able to really kind of make this come together. So these do go together, and I think they need each other. FHIR is a platform, and it's a significant, enabler for deploying these terminology services, and all FHIR applications really need them, because they have to deal with all this complex terminology. And so, together you can do the job better, and this is why I think you guys need them, too. You need to be able to use this stuff in your applications. So, quickly, some application needs, things like you might want to give me a list of codes, or, populate a drop-down, or find out if a particular code is valid, code that I received in an outside, a message, or, from a post or put on my REST endpoint, is that a valid code? Well, I need to find out, so I need ways of doing that. How can I display it? I've got this code, but what is this, what is it? I mean, I need to see a string that I can read, to see, what it is and find out some more things about it. So I need to be able to do all those things. I might need to translate, like I said, from SNOMED to ICD or something like that. I might want to, integrate the search in my application, so I might want to do type aheads or something, and I might need to be able to expand my value set and find out all the codes in it, and then use that that list for what I want to to be able to select as I'm typing away, find what are the right terms that match, and how do I deal with all this changes that are happening in these code systems and everything, and manage those versions and all that. So we need to be able to do all that. And our operations that we have are the ones I was planning to touch on, that basically deal with right now is expand and validate code, and one's in bold. And again, we're running really short on time, but we'll take a look at some of this. And the expand operation takes that value set, the reference, or the resource itself, and returns another value set resource. They're actually both value set resources. But this one, the second one, the output contains the expansion, which is the code set that you would actually want to use. And so default is to do it as of right now. And these are some of the endpoints that ways you can do it. And you can provide additional parameters and all of that, and including the date and and a number of other things which you guys can look at later. And just a quick example of what that would look like. I'm going to click on this. It's already big, so I don't have to worry about that. So this is the value set itself, and this one's an intentionally defined value set. We call it intentional, basically meaning it leverages the hierarchy of the code system. And so it's basically saying I want my value set is all of the SNOMED CT codes that are descendants, they have an is-a relationship, with this particular code. And so it's really simple definition, but then it gets expanded out into, a more complex set. So if I expand it, then I should get another value set resource. Okay. And it's going to have all these codes in it. So these are codes for hypertension. And you'll get a whole bunch of them. So these are all the ones that are descendants of that higher level code in SNOMED. So validate code is basically saying, do I have this code and is it going to be valid? It's basically valid against a value set. That's at least the first, first place to look at it. But we also now have that same capability on CodeSystem. And I'll just hit this real quickly too. But so I didn't even give you a chance to look at the URL. Not sure why that one's taking longer. I don't think we have time for it, but let me do this one. This is against our newest, let me do this differently, because this is the result of that one here, which is based on the code system resource, not the value set resource. And it basically, you can't probably read it, but it says this is true. This, what I passed in here was a true valid code in that code system. Okay. So lookup basically says, let's take a code and find out all the information about it, basically. And I can do additional parameters and things. And I can determine, also can determine whether it exists in the code system, but if it's not, it'll give me an error. But it might only allow you to use one operation rather than two. And we'll do a real quick one of this. I know we're okay, so this one basically says I've got this code, this one's actually from the Australian extension of SNOMED, but it's about pneumonia, and it's got all these, properties and things that you can look at if you need that detail. So that's what that does. And then subsumes, and then I think I'll have to stop, but let's see. So I wanted to show that basically you can leverage the hierarchy here and say, I've got a SNOMED CT code for viral hepatitis, this one, and disorder of liver, this one, and I want to know if one of them is, a descendant of the other. And I can actually do it either direction. I've got both of them on here, but if I do code A, so the question is code A subsumed by code B? So this is code A, this viral hepatitis, subsumed by So I would say, from my clinical perspective, the answer should be yes, it is, because viral hepatitis is more specific than disorder of liver. And if we go look at it, all of these worked earlier. So, yeah, it's probably the Wi-Fi, yeah. All right, well, we are over time. Yeah, the answer should be yes. So anyway, got some more information on Translate and some various ideas. You can look at the slides and get some ideas on how you might use these in your applications to improve performance by doing certain things, and including batch processing and various other things, and some new capabilities we're thinking about, and then let's go over some scenarios and strategies about if you're trying to design data entry interfaces, some things you can do, or creating profiles, or analyzing or validating coded data, or exploring concept relationships and all that. And then you can look at that a little bit more at your leisure, and you can ask any questions after we're done here or at any time and put them on the Zulip chat or in person or whatever. And thank you for coming, and I hope it was helpful a bit. So.